In this video, we will learn how to factor quadratics that are considered special cases. So first, just a quick review of perfect squares. Perfect squares are numbers where their factors are the same. So if I have, for example, 1 squared is 1. 1 is considered a perfect square. Or 2 squared is 4. 4 is considered a perfect square. 3 squared being 9. So this list here, if we were to continue, are my list of perfect squares. So 16 is 4 squared, 25, 36. I'll just make the list a little quick here. 49, 64, 8 times 8. 9 times 9 is 81. 10 times 10, 100. 11 times 11, 121. 12 times 12, 144. These are all our perfect squares. Okay? So if we have a polynomial that has perfect squares as factors, even if that, as the coefficients are perfect squares, we can use that to our advantage. Okay, so there is a little bit of an outline. If I have a squared, a being a number, b being a number, if those are both perfect squares, I can split that into two binomials like so. So a squared minus b squared, if a and b are perfect squares, I can break that into a plus b times a minus c. Okay, so this is just kind of like a helpful rule. I really think once you work through some examples, it'll kind of pop out at you. And plus, with your prior work and the last learning plan of multiplying binomials to get perfect squares, you're going to be seeing that connection a little bit clearly. So here, if I have 16n minus 9, I'm really hoping when you see, especially maybe halfway through the lesson, you're going to start getting more comfortable. I want you to see that 16 and 9 and think, they're perfect squares, right? So I want to split, kind of outline this like I did before into two binomials. And I want to think of two numbers when multiplied that give me 16 that are the same number, right? So 4 times 4, the square root of 16 is 4. So 4n times 4n would give me 4n squared, right? Now, what times what gives me 9? That's the same number as 3. And then really this rule that I shared up here, what's going on is if I put 1 plus and 1 minus, I have no n terms. That's why this isn't a trinomial anymore, right? So we'll look through this and make sense of it. But if I put a plus here and a minus here, if I were to check this now, I have 4n times 4n, 16n squared. Then I have 4n times negative 3 is negative 12n. And then I have 3 plus 4n, 3, positive 3 times a positive 4n is a positive 12n. And a positive 3 times a negative 3 is negative 9. So I'm hoping when you see this written out here, we see this, a negative 12 plus 10, negative 12n plus 12n cancels, right? That's 0. So then we see here that we're left with 16n minus 9, which is what we had originally, right? So this rule, when I don't have that middle term of that, my single variable of n or x, whatever my variable is, they disappear when I have this plus and minus because they cancel in the middle. So that's where this outline helps. If I have perfect squares that I can clearly see, then just putting a plus and minus gets rid of those middle terms, right? I'm just left with my two outer ends. So if we look at the next one, 4m squared minus 25. So you want to think of what times what. That's the same number. Gives you 4. Right? So this, basically you're taking the square root. You're taking square root of 4, which is 2, and keeping that m there. Now what times what equals 25 is 5. Now again, to get rid of those middle terms, we're just doing 1 plus and 1 minus. It does not matter where those live. If you made this minus and this plus, it would still be correct. Let's look through a couple more. We have 9n squared minus 1. So 9x squared, we can put that into two factors of 3x and 3x. And the factors of 1, or the square root of 1, is 1. Again, 1 plus and 1 minus. So n times n gives me n squared. I'm going to rewrite that. 5 times 5 gives me 25. And I have a minus and a plus. Again, the order doesn't matter. Next, 400. Square root of 400 is 20. 20 times 20 gives me 400. 6v times 6v gives me 6v squared. 1 plus, 1 minus. Next, I have 7x times 7x gives me 49x squared. And 10 times 10 gives me 100. 1 plus, 1 minus. So again, this kind of shortcut rule only works if you're subtracting, right? If you're subtracting two terms that are perfect squares. It does not work if this is plus, right? It only works if it's subtract. So really, being you're not going to have, 6 questions all the same on the test like this, when you're practicing in IXL, the lesson is a special case only, but the last IXL lesson of this whole learning plan mixes all these factoring questions up, so it's not all the same. So the strategy really is similar for all of them, but they are, all a little bit different. So make sure you do that last IXL lesson, because again, it mixes them all up, and that will be a really good indicator of if you're truly understanding factoring.